Hello students, welcome to the next lecture on the CSIR net examination. Today we will discuss the part 2 of this linear algebra question. We discussed 5 questions in our last lecture. Now we will discuss question IDs 297, 299, 375, 377 and 380 with the help of shortcut tricks. Myself Dr. Garg. You can simply follow my YouTube channel Dr. Harish Garg, or else simply follow my Telegram channel where you can find the various lectures related to the CSIR net. You can follow this playlist CSIR net GATE IIT JAM, where you can find all those previous year papers with the help of shortcut tricks. So let's start with these 5 questions. We can deal this with the help of shortcut tricks. So if you start with this first question, that is a 297, what is given to you? A and B are similar matrix. So what is the meaning of that? A is similar to B. What is the meaning of that? It means there exists a matrix P which is called as invertible matrix, such that you can write this A as of this form. But here it is, say you can see this is a typing error. Okay, there is a typing error here. So actually this will be, there exists an invertible matrix S such that it will be here. Then what will happen of this P? So remember that there is a first beautiful result for you. So you can see whenever A is similar to B, this implies characteristics equation of A is same as that of the characteristics equation of B. It means the determinant of A is same as that of B. It means the trace of A is same as that of trace of B. It means the minimal polynomial of A is same as that of the minimal polynomial of B. It also says that eigenvalues of A is same as that of the eigenvalues of the B, and so on. Also, if A is similar to B, then it implies A transpose is similar to the B transpose. These are the some common tricks, or you can say you have a tips for you if anybody need it in your other examination. Remember, all are in this way, but if you want to see on this side, then it will be applicable only for 2 cross 2 and 3 cross 3. It means if you have a 3 cross 3 matrix, then if satisfy any of the condition, then you can say they are similar. But if it is a 4 cross 4 or 5 cross 5 or more, then this does not imply B. So make sure this is one of the important tips for you. Now, if you know these tips, you can solve this question very simple. What is given to you? A is similar to B. Transpose of A is similar to the transpose of B. That's a simple standard result. That is a correct statement. But we need a false statement. So this, it means this is not the right answer. So it means, but this is my correct statement. Minimal polynomial of A is same as that of the minimal polynomial of B. Look at that. This is also the correct statement. Trace of A, trace of B are also be the same. That's the correct statement. So which of the following is true? Is not true. It means there is only one correct option, that is my here. Look at that, there is a trace of A, but you can't say that the range of A are same. That's very simple. If you simply consider the two matrix, say 0 1 0 0, and say B is my 0 0 0 1, clearly say that what is the range of this? What is the range of this? This is nothing but my 0 1, and here is 1 0. Now it's my 2 cross 2 matrix. So you clearly say that this implies here. What is the characteristics equation? The characteristics equation of A, characteristics equation of B are same. Determinant of A, determinant of B also same. Trace is also same. Minimal polynomial of both of them same. Eigenvalues are same. So this implies A is similar to B. But the range space of this is 0 1. This is my 1 0, which is not same. So hence the answer is my here. So remember, this is the tips for you which may be helpful in your other examination. Okay, look about this next question. This is the question ID 375. What is given to you? A is a n cross n matrix such that A and A square has same rank. So rank of the A and rank of the A square. This is my same. Okay, fine. Consider a transformation here. Then which of the following statement are true? It may have more than one correct option. Kernel of T, T, and then so on. So firstly, there is a T circle T. What is the T circle T? So we can see if we apply the mapping V So what will happen of this? So this is my here. What is the T of V is my AV. It is given to you. And what is that? This is nothing but A square V. So what is the meaning of this cases? It means if I apply the mapping, the transformation, this is my A. What is the matrix associated with this is A square. You can see that. Fine. Now what is given to you? Rank of A is rank of A square. So if I subtract n from the both side, what is the meaning of that? That is a dimension, that is a range of A square also from here. So this also implies once you subtract n minus, that's a nullity. So it means the kernel dimension of this T, kernel of A is same as that of the kernel of A square. That means kernel of T and this is the kernel of T circle T are same. So the kernel of are same. That's the answer. Now once we know that the range of this, what is the meaning of that? That means you can see from here dimension of this kernel is same as that of the dimension of this kernel. So it means these are also the correct options. Now they are talking about the A. What is the A is? A is a n cross n matrix. What is the value of the n? You can choose any of the say 2 cross 2. Choose any of the 2 cross 2 such that A and A square has same rank. So what you can do that? You can simply take A is 0 0. So what is the A square? It is also 0 0. So the rank are same, but A is not an invertible matrix, so it is a cancel out. I plus A must be invertible B. So that's very simple. It means what is the eigenvalue of this is 1 1 1 and so on. If I choose any of the matrix A whose eigenvalues at least one of them is 0, 1 of minus 1, then if you take the addition, then that eigenvalue is 0. So if I simply consider this are there, fine, there is no issue about that. Or you can simply take A is my minus of I, for example. Then what is my A square? This is I. You can see the rank of both are same. That satisfy property. So what are the eigens values of here? This is a minus 1, minus 1. So if I consider 2 cross 2, then what is the eigenvalue of the I plus A? 0 0. So once the eigens values are 0, then what is the determinant of this I plus A is a 0, which is must be the invertible. That is not be again correct answer. So the right answer is A and B. That's a very simple task. Okay, look about the next one. So this is the bilinear form. That's the inner product space is given to you. Which of the following statement is correct statement? Okay, they are talking about the orthogonal, orthogonal, orthogonal and orthogonal. So we all know what is the meaning of the orthogonal when their inner product will be 0. So it means your target is to prove that will be 0 for the corresponding pairs. That's a very simple question about that. If you look about the options, nothing is to be needed to solve them. This is given to you. If you look about this option, what is the difference between them? They are taking only in this case, you can see that the only case is my A is equal to 1, and you can clearly see that here. Anyhow, let's start with this first case, AX plus B and the X plus C. Your target to make them as a 0. What is the meaning of that? You can take the integration. So this is the AX plus B and X plus C will be here. So we have to find the value of A, B, C. So if you integrate them, this is the AX square. So it's A by 3. This is A C X square by 2. I take the limits 0, 1. This is a B by 2 plus BC is a 0. Now we need to find the value of C. So I can find the value of C from here. This is minus A by 3 minus B by 2 divided by A over 2 plus of B. Now we can think about here. For every non-zero real number A and B, so I can choose A as a 1 and B as a minus 1 by 2. What is the C? C is a infinity. There exists a real number C, which is not possible. So it means that option is cancelled out because we need a true statement. What about in this case? These are similar to them. The only difference here is a is my 1. Fine. So if I take a is equal to 1 as of this, again b is minus half. There exists infinitely many real numbers c. Again, this is not a correct statement, because once you take a is 1, b can have any non-zero number. Again, b I take as a minus half. Then c becomes a infinite. So infinitely many real number, but it can't be possible that. Again, it is not possible. Look about the third one. Again, ax plus b and x plus c here is there, but in this case you have to find the value of a and b. So instead of this, I can start from here. Let me firstly do the fourth part. For every non-zero b, there exists infinitely many c. So I can take b and x plus c integration over the 0, 1. It should be 0. So what will happen? This is b upon 2 plus bc is 0. So for every non-zero b, so I can take b as a common and cancel out. So it means c must be half. But they are saying that infinitely many values of c. But that is not true, because this is only possible for minus half. That's a unique value given to you. That option is cancelled out. Only option is my here. So how you can solve that? Again, there exists so what you can do, you can take c on the right hand side and you can find the value of c. So there is a positive real number. Now you can see this number is my positive. It means this number is my greater than 0. Fine. So what is the meaning of that? If this number is greater than 0, what is that? This is a over 3 plus b over 2 is my less than 0. So how many values of the a and b for which these conditions satisfied? There are infinitely many pairs of the a and b. So that's why the right answer is only C is my right answer. Look about the another one. This is again the unit 1. That's again the unit 1. That's a very simple question will be there. A positive integer n which is greater than equal to 2. So that's I can simply take n is 2. Such that A is my n cross n matrix and A of n square has a rank 0. Fine. So if I consider n is my 2, it means A raised to power 4 has a rank 0. Fine. And 0 is my n cross n, all the n, that is a 0 matrix. Which of the following statements are equivalent to the n independent linear eigenvector? What is the meaning of that? When you can say it has n linearly independent vector, it means the matrix is diagonalizable. Fine. Now what is given to you? A of n square has rank 0. That means here, what is the meaning of that? It means A is nilpotent matrix. Fine. So once you know A is your nilpotent matrix and you have to find the condition that this is A. Now I found A is nilpotent matrix has eigenvalue plus A is my diagonal matrix. This is given to you. So what is the condition of that? So you all knows that there is a one result. If A is my nilpotent matrix, A is my diagonal matrix, then if and only if A is my 0. Remember, this is the only result. Whenever A is nilpotent matrix and A is diagonal, it means A is always my 0. So which is the option is? This is the correct option. Another method, you can see if you forget about that, you can think about here. Second method is, because we know that A of n square is 0, that's a is nilpotent matrix. What is the meaning of that? A of n is my 0. Fine. So what is the meaning of that? The characteristics equation is, this is my characteristics equation. Now if I find the minimal polynomial, what is the minimal polynomial is there? This is my minimal polynomial, because what is a minimal polynomial? That is a non-repeated linear factors are there. So once it is a minimal polynomial, so we all know the annihilators are the roots of this. So it means what is the meaning of that? The matrix A is my 0. So that's the condition of this. So that means A is equal to 0 is the right answer. And you can see A and if simply take n is equal to 2, for example, then these two cases are same. Okay, so that is not be possible about that. And A4 is that again not possible. You can simply take 0, 1, 0, 0. very simple is there. Then what is will be my a square? A square will be my 0 0. Fine. So this satisfy here, but this is a nilpotent matrix R. So clearly say this is not a nilpotent and this one is there. Okay. Look about this another question. That is capital T is my transformation on the W such that it's on the complex differentiation. That means if I take a mapping F, it will be my on the complex differentiation. That is my given to you. Which of the following statement are correct? That's a very simple about that. Dimension, span, Jordan block are there. Okay. So firstly, what is the Jordan block? I think all of you know that what is the Jordan block. Jordan block is a matrix. Remember that. It is a matrix. Okay, fine. It's a matrix. Okay, what is the span? What is the span of F1 and F2? What is the meaning of the span of the F1, F2? That is a vector space. So it means second option is cancelled out. Clearly says that because this part, what is that? This part is my vector space. This part is a matrix. So matrix can never be a vector space. So this it doesn't imply that. So it means the second option is clearly cancelled out. Okay, so now we look about this another option. So dimension. What is the meaning of the dimension is Li. Fine. So how you can check the dimension of this? So if I take alpha 1 of F1 is my, I can written as sin Z, alpha 2 cos Z, alpha 3 sine of 2Z, and alpha 4 of cos of 2Z is 0. Now how your target is to check whether all of the alphas are 0 or not. That's a very simple. Say Z is 0. What will happen? This is 0. Sin Z is 0. So alpha 2 plus alpha 4 is 0. Fine. If I take another number pi, because if you take pi, this is again 0. Cos pi is my minus 1. Sin 2 pi is 0. Cos of 2 pi is my plus 1. So what is the meaning of that? This implies both are my 0. So it means this part is 0. This part is 0. Now for other part, how you can take that? I can simply take as a say pi by 2, because sin pi by 2 is 1 and this sin pi, that's a 0. So alpha 1 is also be a 0. Now for that you can simply take of any number, say 2 pi. So it's a sine of 4 pi is a 0. So this will be 0. Or you can simply take pi by 4 you can take. If you take pi by 4, then it will be sine pi by 2. Sine pi by 2 is 1, so alpha 3 are 0. So all the alphas are 0. It means they are Li. So it means what is that? The W consists of these 4 elements. So what is the dimension of these 4 elements? That is my 4. But they are talking about the 3. That is also be a cancel out. Now you have to find the Jordan blocks. How you can find the Jordan block? You have to construct the matrix. So I can clear this screen firstly. So firstly you have to find the basis. So what is the transformation is of any is complex differentiation of F. So what is the basis? So you can write this matrix. The first one is my F1, F2, that is my sin Z. This is my cos Z. This is my sine of 2Z and this is my cos of 2Z. Now first, what is the derivative of this? That is my minus of cos Z. So that's my second element is 1, rest are 0. What is the derivative of this? Sorry, cos is plus sine. Sine is plus cos. Cos is minus sine. So it is, this is minus 1, this is 0, this is 0, this is 0. 2 cos of 2Z. So cos of 2Z, this is my 2, rest all are my 0. This is my minus of 2, rest all are my 0. Fine. This is my matrix capital T. Now we can define the blocks. So these are my blocks. Fine. So what is the characteristics equation of this? This is my lambda square plus 1. What is the characteristics equation of this? Lambda square plus 4. So it means what is the minimal polynomial of this? So that is the characteristics equation of the complete matrix. So what is the characteristics minimal? That's a non-repeating. That's the same thing. That's also be the same thing. So what are the eigens values of this matrix? So plus minus iota, plus minus 2 iota. Now we can define the Jordan blocks. So these are the eigenvalue iota, then minus iota 0 0, 2 iota, minus of 2 iota 0 0. Now you can see each of the eigenvalues are distinct. So how many blocks will be there? This is the first block, second block, third block, fourth block. So these are the 4 blocks. This option is cancelled out. So right answer is my only D is my correct option. So this is the way you can simply solve this linear algebra questions. I hope you can simply learn the various tricks in this lectures too. We will see the next lectures on some differential equations. Till then you can simply follow my playlist CSIR Net, where you can find all those videos with the help of shortcut tricks. Till then you can simply like, share and comment on my these videos. Best of luck students. Happy learning.